Good morning. Welcome to the session on digital signal processing, chapter 2. So, efficient computation of DFT. So, in the previous class, we have saw how to solve an example of DIT FFT method. Okay, using the flow chart or a butterfly diagram. Today we'll revisit the topic of DIF FFT. We started and we initiated the procedure due to the network issue. Here and there might be a confusion for students. So let me revisit quickly to the derivation part of DIF FFT once again. Then we will solve one example using DIF FFT and we'll wind off that particular topic by today. Okay. So if I complete this topic, we're left with another simple topic. So that is applications of DFT. So that could be take me around 2 hours. So that we will finish the unit 2 as well. Okay. I hope my screen is visible. Okay. So anyways, today I have joined with one more device. So will be getting intimation if I lose my connectivity. Okay, quickly we'll go to the topic of DIF 50. Okay, uh, this was the topic that we were discussing in the last class, decimation in frequency FFT. So today we'll directly start with the derivation part once again. So I'll keep this slide as it is for your reference in the later case. But still today we'll start with once again the derivation part, so that will be much more comfortable for you guys. Hoping so. Okay. So we already know that DIF FFT DIF-FFT, where we consider the x of n signal, and x of n signal comprises of some samples running from 0 to x of n minus 1, where which means that there are n samples, right? So within these n samples, what we do is we divide the and first half and the next half or last half, I can say. Okay, which means that there are n samples. What we do, we divide n by 2 samples and n by 2 samples. In earlier case, that is in DIT FFT method, we divided x of n sequences in terms of odd sequence and even sequence. Ultimately, make sure that, so this is a decimation. What do you mean by decimation? It is nothing but divide. So you have to divide your sequence, input sequence x of n, in either of the form, right? So in the previous case, we decimated the x of n sequence in terms of even and odd. Now we are decimating the x of n sequence in terms of the first half sequence and the last half sequence. As per the definition of the DFT, the definition stands like this. So this is summation n runs from 0 to n minus 1. Your input x of n is multiplied with the Twiddle factor Wnkn, where the k value is also going to be ranging from 0 to n minus 1. So as per my definition of DIF FFT, I should divide the x of n sequence into odd and even. So how do I do it? So this is x of k is equal to the first half sequence. that is starting from 0 to n by 2. So if I take those samples, then my starting signal will be obviously 0, but the last sequence is n by 2 minus 1 sequence. So I take x of n wn kn, along with that plus, once again, the next sequence will be starting from n minus 2, n by 2, right? So after n minus n by 2 minus 1, the next sample will start from here and up till last sample. So this is my next samples of x of n by 2. Now all the time make sure that my summation should start with 0, right? Accordingly, what I do is, so this is the equation 1 and this is equation 2. So altering my equation 2, the second portion, so this is first half and this is second half. Fine. All the time my intention is to make sure that the summation should start with 0, because all the standard summations are either from minus infinity to plus infinity or 0 to some value, right? So in that perspective, what we do is, I try to make sure that this is also going to be starting from 0 to n minus 1 and the first part remains same, no change in it. Okay, plus here I simply state this as n equal to 0. When I say that n equal to 0, now how do I come to this particular point? How do I come to this particular sequence? It is as simple as x of n plus n by 2. So look at this. If I consider n equal to 8 point DFT, now the first half is from 0, 1, 2, 3. So here it will be done with that. Now I should start with fourth sequence. How do we do it? So obviously if I put 0, so this is 8 by 2, then obviously I'll come up with a fourth sequence itself. Is it not? So what I do? So n changes to n plus n by 2. Similarly, here also the small n changes to n plus n by 2. Is this clear? Now, till what value we will move? From 0 to, obviously the last sequence is n by 2 minus 1. So look at this. Now the summation of first sequence and the second half sequence remains same. So this is first half sequence and this is second sequence. Summation is same, but the twiddle factor can be multiplied, right? Just observe carefully. I'll try to multiply the twiddle factor here. So x of k is equal to, x of k is equal to, going back, so this is first half sequence summation, n runs from 0 to n by 2 minus 1, x of n w n k n plus, okay. Now look at the second half sequence. So it is also running from 0 to, this is n by 2, so this is second sequence is summation, n runs from 0 to again n by 2 minus 1, x of, not n, it is n plus n by 2 sequences. Now twiddle factor is to be multiplied. So what we do is wn kn into wn kn by 2. Okay, let me multiply the k value inside. So that is wn kn into wn kn by 2. Is it not? Okay, now we know that wn to the power of n by 2 is equal to minus 1, right? So I can write this particular portion, okay. Look at this, wn to the power of n by 2, can I write like this, whole to the power of k. So what happens? So this value is nothing but minus 1. So I try to write this as minus 1 whole to the power of k, remains as it is. Now look at this. The summation is ranging from n runs from 0 to n by 2 minus 1. There is no point of keeping this minus 1 whole to the power of k within this summation. It doesn't affect. So let me take out this portion outside. So what happens? X of k is equal to summation n runs from 0 to n by 2 minus 1 x of n wn to the power of kn. So I am taking this outside, this portion outside, this portion outside. Okay, so this is equal to what? Minus 1 whole to the power of k. So I keep this as minus 1 whole to the power of k. Next, the summation remains unaltered within this. So this is, it doesn't affect my summation. That's what I'm trying to say here. That's it. Wn to the power of kn. So rest of the equation remains as it is. So right. So now you got the point, I hope. Now, what is the common thing that here I can? Okay, here one important point here it is. There are this k value, which means the entire, let me call this as equation number 3. The equation number 3 is depending the output x of k is depending depending on whether k is even or k is odd. Am I right? Because I'm going to get, if k becomes even value, then this is a summation of first half sequence and second half sequence, right? Next, if k value is odd sequence, like 1 3 as such, then the x of k value will be the first half sequence minus the second half sequence. This is the difference over there. So what we do is, let me take k is even. If k is even, right, then that is, how do you write the k sequence as even? So I should consider in terms of the mathematically, if I want to represent any even sequences, I will be representing some factor that is multiplied by 2, and I consider that factor to be r here. Okay, now which means that x of 2r, which means I'm trying to take only the even sequences. Okay, now the equation 3 is going to be modified as, so equation 3 is represented as below, right? So that is x of 2r is equal to n runs from 0 to n by 2 minus 1 x of n wn. What is k? K is nothing but 2r. So I'll put, instead of k, I'll replace it by 2r to the power of n, plus minus 1 whole to the power of 2 into r, summation n runs from 0 to n by 2 minus 1 x of n plus n by 2 wn, again 2r n. Now look at this, minus 1 whole to the power of 2r is nothing but all the time minus 1 whole to the power of 2, right? So I can write like this. So all the time this is 1, right? So what we do, so this I'll just replace this as summation n runs from 0 to n by 2 minus 1 x of n wn. I can write this wn to power n as what? wn by 2. So this I can take like this. So you already know this. So this change I'll do it here. So it is not wn to the power of 2. I make it as n by 2 point DFT r into n plus. So I'll keep as it is. Now minus 1 whole to the power of 2r, which is nothing but 1 itself. So that I'll ignore here. So let me erase this. This is not required. Okay. Now summation n runs from 0 to n by 2 minus 1 x of n plus n by 2. Same thing I perform here also. This is wn to the power of rn, and 2 I will take it below this n. So that is n by 2. Just a minute. Hello Shrikant sir. Hello Shrikant. So after this, so observe carefully. Summation x of the first half summation and second half summation, I can take out the summations which are in common. So both are in common, and wn by 2 to the power of r n in first half, here also it is present and here also it is present. So I'll take them outside as a common factor, so that this x of 2r will be equal to summation n runs from 0 to n by 2 minus 1. Okay, x of n plus x of n plus n by 2 into wn by 2 to the power of rn. So here also it is x of n plus x of n plus n by 2. If I call this as one input signal g of n, so what it is now, x 2r, x of 2r is equal to summation n runs from 0 to n by 2 minus 1. I call this as entire thing as g of n wn by 2 to the power of rn. Now this is nothing but what we have applied k equal to 2r, that's it, which is nothing but still a DFT it is, right? So where r is ranging from 0 half portion, that is again this value will be from 0 to n by 2 minus 1, and it is a n by 2 point DFT, right? So here I am getting half portion, so I am going to get only even sequences of x of k. So output x of k is even sequences, or will be in terms of even sequences. So here I am going to get x of 0, x of 2, x of 4 output as such, right? Similarly, if k is odd, how do you put it in mathematically? K equal to 2r plus 1, where in which equation you will put this? So let me go back, and here in the equation 3 I will put for odd sequences, that is put k equal to this in equation number 3. So this is equal to x of 2r plus 1 is equal to summation n runs from 0 to n by 2 minus 1, right? Now going back, let me see, x of n wn to the power of 2r plus 1, right? So that is x of n wn, so here it is going to be 2r plus 1 into n, and minus 1 whole to the power of 2r plus 1 will be, so since it is odd, so I'll just write minus, because the entire thing will going to be minus 1 there. So again summation n runs from 0 to n by 2 minus 1, x of n plus n by 2 wn to the power of, so what it is here, kn. Instead of kn I will be writing this as 2r plus 1 into n, right? That's it. So finally I can write this once again by splitting wn to the power of 2r plus 1 by multiplying with this small n. So I'm going to get this equation as n equal to 0 to n by 2 minus 1 x of n wn to the power of 2rn into wn to the power of n. Simple, right? Similarly, minus summation n runs from 0 to n by 2 minus 1 x of n plus n by 2. Here also wn to the power of 2rn into wn to the power of small n, right? So here I try to represent this as n by 2 point DFT here, because it is wn to the power of 2rn. I take it 2 here in the below n, as well as here also I take this as a n by 2 point DFT. So in the last stage, the equation will looks like this: summation n runs from 0 to n by 2 minus 1. Okay, what we do is, so this is entire thing is in common, right? So that is x of n, okay, plus x of, sorry, it is minus here, so it is not plus, it is going to be minus, minus x of n by n plus n by 2. Okay, just take out the common factor, that's it. So what we left with, w n by 2 to the power of rn into w n to the power of n. This is what we left here. Am I right? Okay. Now moving further, I just represent this x of n minus x of n plus n by 2 by another variable called h of n. Okay, so that, and again here, the till here, this entire thing is n by 2 point DFT, that h of n. So this entire thing is getting multiplied with a twiddle factor wn to the power of n, right? So this is once again the odd value or odd sequences of x of k will going to be obtained, are going to be obtained by using this equation. Therefore, so x of odd sequences, x of 2r plus 1, I will represent this in the form of summation n runs from 0 to n by 2 by 2 n by 2 minus 1. I write this as h of n into wn to the power of n. Okay, so this is my final equation for odd sequences of x of k. So let me represent this as a equation number 5. Here I am going to get x of k in the form of odd sequences only, that is x of 1, x of 3 as such, right? So where g of n was uh, g of n was input, the first sequence input x of n, plus the next half sequences, right? Whereas h of n is nothing but x of n plus w, sorry, it is not plus, I'm sorry, x of n minus n by 2, and entire thing is going to be multiplied with wn to the power of n, right? So this is, I'll going to multiply with, so this entire thing will be h of n, and that value is going to be multiplied with wn to the power of n. So here, if you want to calculate g of 0, so it is just like, look at this, I put a small block diagram here. This is n by 2 point sequences of I have n by 2 point output here, and here also n by 2 point output here, and here from the first half sequence I am going to get the even sequences of x of k. So that is x of 0, x of 2, x of 3. Let me assuming that n equal to 8 I am speaking, okay, x of 4 and x of 6, right? And next half sequences are x of 1 odd sequences, that's it, x of 3, x of 5 and x of 7. Is it? So this is this is how we are getting, we are fetching these first half values from this equations. If you observe carefully, this is the equation that we are, so let me call this as equation 4. This we have not represented, right? So this is equation 4. From equation 4, if you observe carefully, I am going to get only the even sequences of x of k. That's what I wrote here. So this is even sequences of x of k obtained from g of n. Okay, now this is odd sequences of x of k, odd sequences of x of k obtained from h of n. Okay, how do you obtain? So that is g of 0 here, g of 1, g of 2, g of 3, right? Here h of 0, h of 1, h of 2, h of 3. How do you obtain h of 0, h of 1, h of 2, h of 3? And how do you obtain it? G of 0, g of 1, g of 2, g of 3? It is nothing but we obtain this g of n and h of n by taking x of n first half and next half of x of n, right? Either we perform addition or we perform subtraction. That's it. So that's where my complete figure, right? I go with putting this. I'll continue the uh, right. Okay, so here is my signal x of 0, x of 1, x of 2, x of 2, x of 3, and x of 4, the next half, x of 5, x of 6, and x of 7. Let me change the ink so that it will be clear to you. Okay, now to get g of 0, g of n. Okay, in general, if I want to get g of n, so where n equal to 8 point, so how do you obtain g of 0? Here first sequence, it is nothing but x of 0 plus x of 0 plus 8 by 2, which is nothing but x of 4, right? So how do you obtain g of 1? X of 1 added with the next half sequence, that is x of 5, right? So g of 0 is going to be obtained from x of 0 is added with x of 4, x of 4. So now you got this as g of 0, right? So again, to obtain g of 1, it is x of 1, and that is going to be added with, g of 1. Then similarly, g of 2 is obtained from adding the two sequences, that is x of 2 plus x of 6. So you are going to get g of 2. And finally, the g of 3 is going to be from g of 3 added with x of 7, right? Now you got a sequences of g of n, where g of n, g of 1, g of 2, g of 3 in turn is going to get you the sequences of x of k, which are only the even sequences, right? Now next, how do you obtain the h of 0 and h of 1, h of 2 as such? So it is very simple. Again, look at this. H of 0 is going to be obtained from x of 0 minus x of, this is again, sorry, this is not this remains same, only the middle minus is going to be changed. So again it is x of 4, but entire thing is to be multiplied with one more middle factor, that is n equal to how much? N is 8 point DFT here, and n equal w8 to the power of 0. So that's how h of 0 is going to be obtained. Similarly, h of 1 equal to x of 1 minus x of 5 I subtract, and entire thing is supposed to be multiplied with what? W8 to the power of 1. So it is very easy for me to obtain the h of n sequences. I just multiply this sequence. So h of 0, so h of 0 is obtained from x of 0, right? And this is to be negated minus 1. So this value, so that value is to be subtracted, and it is going to be multiplied with finally w8 to the power of 0, so that you will going to get h of 0. And further, so this is x of 1, x of 1 is subtracted from x of 5, and then multiply the sequence with w8 to the power of 1, so that you will going to get h of 1. Similarly, x of 2 is subtracted with x of 6 minus 1, and then multiplied with w8 to the power of 2, h of 2 is obtained. Similarly, h of 3 is obtained from, I don't mark that, so it will lead to a confusion. It is nothing but x of 3 minus x of 7, and then it is multiplied with w8 to the power of 3. So I hope you got the first half point here. The first half point, that is first stage, I mean to say. The first stage, what we did here, the x of n sequences are divided into first half and next half. Then we obtain g of 0, g of 1, g of 2, g of 3 values. Then further, by using this, we obtain x of 0, x of 2, x of 3, x of k values, where x of k values are going to be divided in the form of even sequences and odd sequences. Now once again, g of 0, g of 1, g of 2, g of 3, h of 0, h of 1, h of 2, h of 3 are the form of, are obtained from the input signal x of n itself, which means I can still divide this, decimate g of 0 to g of 3 as first half and next half. Okay, so this is first half of g of n sequences and second half of g of n sequences. Then further, I can also split this h of n sequences as first half and next half, right? So that I can come from, this is now n by 2 point DFT means 4 point DFT and 4 point DFT. Again, if I split this, again it is going to be a 2 point DFT, 2 point DFT. So again 2 point DFT and 2 point DFT, right? Where this sequences is going to be like this. So this is what the first half sequences, as I mentioned, and this is going to be a first half sequences, right? So this is going to be a first half sequences. If I split further, so I am going to get these kinds, right? So n by 2 point DFT, n by n, instead of n here it was n by 2 point DFT. Now this will be n by 4 point DFT. What is to be, what you are going to get? So here what is going to be the output? So here the output was x of 0, x of 2. Again within this output will be even sequences and odd sequences. If you fetch the even sequences output out of this, so that is x of 0, x of 2, and odd sequences are x of 4. Odd sequences are x of 2, x of 6, right? Again within this even sequences are x of 3 is one even sequences, x of 7 is one more even sequences, and again my output will be split into the odd sequences of this x of 1 to x of 7, that is x of 1 and x of 7, x of 5, x of 5. Fine. So that's where your final output, your final output, x of 0, x of 4, even sequences of the first part of that. So next x of 2, x of 6, next x of 1, x of 5, x of 3, x of 7. If you observe carefully, your input is regular in order, but x of k is now bit reversal order. Okay, in case of DIT FFT, input was bit reversal order, output was regular order. And if you observe carefully, this stage was the last stage in calculating the DIT FFT method. This was somewhere else the middle stage, right? So in DIT FFT method. So that's where if you try to implement the final signal or the final DIF FFT method. So this is entirely reverse process of DIT FFT method. If you observe carefully, so this was stage 3 in DIT FFT, but in case here it is stage 1, and this was obviously stage 2 in both the cases, but here this was the stage 3 in DIF FFT. Okay, DIF FFT, but here there it was the first stage in DIT FFT method, right? So this is how we obtain the calculation of DIF FFT method. So I hope today the derivation is much more clear for you guys. And final block diagram, if you go on splitting this, so you're going to get in this form, no doubt at all. Okay, is this clear? You can give me the chat messages. Okay. 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 Now quickly we will solve one example from considering the DIF FFT method, and so that you can understand in a much better way how to solve the example. In examination, you will be asked to either to derive a DIF FFT method or DIT FFT method equations till from n point to n by 2 point DFTs. Okay, you are supposed to write the derivation completely starting from the first stage to last stage, or else you will be asked with either of these two types of problems, right? So now, given sequences is x of n is equal to n plus 1. Try to write the sequence of x of n here. What is x of n now? So x of n is given as x of n is going to be x of n. So if I put n equal to 0, then the first sequence is 1 itself. If I put second sequence is n equal to 1, then the sequence is 2 and 3 and 4, 5, 6, 7 and 8. So this is x of n plus 1. So you have a 8-point DFT where n equal to 8. Okay, so try to solve this. X of 0 equal to 1, x of 1 equal to 2, x of 2 equal to 3, x of 3 equal to 4, and this is 5, and this is 6, and here it is 7, and here it is 8. Now, find out the value of this stage. What is this stage? Here we will going to get g of 0 sequences, right? G of 0. What is g of 0? It is nothing but the addition of first half and the next half the first value, that is this plus this. So this gives me 5 plus 1, 6. Now calculate g of 1 here. Calculate g of 1. Calculate g of 2, g of 3. So finish up these calculations and start giving me the answers in chat box. you can, if you have any confusion in calculating, so you just write the definition here. G of n is nothing but x of n plus x of n small n plus capital N by 2. So this is, you try to write it here. And what is h of n? And h of n is given by x of n minus x of n plus small n plus capital N by 2, and that is supposed to be multiplied with a Twiddle factor Wn to the power of n. 6, 8, 10, 12. Good. So this is 6, 8, 10 and 12. Right? Now calculate h of 0. h of 0. h of 0, similarly perform subtraction with this, that is 6, here 1 minus 5, and that the value is supposed to be multiplied with what? W8 to the power of 0. What is W8 to the power of 0? Here it is 1. You already know these values. Okay, I already told you how to calculate these values here. So quickly give me the answers for h of 0, h of 1 and h of 2. So here h of 0 equal to and h of 1 equal to. So h of 0 is minus 4, obviously. Correct. Very good. Then what about h of 1? h of 1. So it is nothing but 2 minus 6. It is minus 4. The minus 4 is supposed to be multiplied with W8 to the power of 1. What is W8 to the power of 1? It is J, I think. Right? So W8 to the power of 1 is 0.707. So I write the values here. W8 to the power of 1 is equal to 0.707 minus J 0.707. W8 to the power of 2 is equal to J. Okay, it is minus J. Okay, W8 to the power of 3 is nothing but a conjugate of W8 to the minus 0.707 minus J, not conjugate, just negate the first value, right? So this h of 1 is equal to how much? No, it is not 4J. This comes to be different value. Minus 2.828 plus J 2.828. See, W8 to the power of 1 is not J. You are trying to multiply with J. W8 to the power of 1 is 0.707 minus J 0.707. This is where you are making a mistake, guys. Karthik Gandiger, Geeta, Vijay Lakshmi, Agna, not Agna. So, Silpa. So, you guys are committing a mistake here. Yeah, Preeti. You got the correct answer. That is minus 2.828 plus j times 2.828. So I'll just show you how it is. So here x of 1, this sequence is nothing but x of 1 minus x of 5. That value is to be multiplied with 0.707 minus j 0.707, right? So what is the value of this? It is 1 minus 6, 1 minus 6, sorry, the 2 minus 6, that is minus 4. Minus 4 into 0.707 minus j 0.707. So if you multiply this value, we are going to get minus 2.828 plus j 2.828, right? Okay. Hello. Okay, x of 5. Can anyone? So Abhay Bhatt, is there? Are you there? Me out in writing the answers for what is the value of x of 5. Prajakta,
Yes, sir.
x of 5 value
1.656
1.656,
6
yeah,
plus 4j.
okay, plus 4j. X of 3 value
X of 3 minus 4
minus 4
plus 1.656
plus 1.656j.
j
Okay, then last value x of 7
minus 4
minus 4
minus 9.656j.
656j. Okay, fine. Now you should write them in order. Okay, x of 0, then followed by x of 1, x of 2, then followed by x of 3, x of 4, and followed by x of 5 and 6 and 7, right? Now look at that. Can you able to see the complex conjugate? And obviously x of 0 must be 0 dc component, x of 4 also dc component, so there is no j term. Okay, because this is n by 2 point dft, n by 2 point sequence. And here 2 and 6 are complex conjugate, right? X of 2 is equal to x conjugate of 8 minus 6, it is 2, right? So obviously you will going to get complex conjugate. And similarly 5 and 3 are complex conjugate, not 5 and 3, right? 5 and 3, are you getting complex conjugate here? Oh, these values somewhere else you we missed it here. 1 and 7, I think we missed the value somewhere else. Look at this, just check these answers. Okay,